ACT Science is my own personal tutoring packet. This is part one. Probably 4 parts, hopefully 3. Um, for those who haven't used these videos before, you want to use the pause button a lot. So watch what's going on, pay attention, hit pause, do some of the work on your own, go forward from there. So what's on the ACT Science? There's 40 questions, and it's in 35 minutes. Once upon a time, it was 7 passages, and now apparently it is 6. But sometimes we have seen 7 passages, so watch out. And they are called passages. They're labeled passage 1, passage 2, so on and so on. Time is the biggest issue on the science portion of the test, mostly because it's your 4th test. You have your English test, your math test, your reading test, and now your science, and people are just wiped out. It also is highly detailed reading, really, really detailed reading, chart analysis, graph analysis, and then synthesis of information. It's challenging, very challenging. So I'll be short, to the point on this page. You can read through it in your own sweet time. You have 3 types of passages: charts and graphs, which is usually 2 passages; experiments, which are 3 passages; and then conflicting viewpoints, theory or fighting scientists, which is 1 passage. And I'll show you what all this looks like. Understand that this is also in terms of difficulty. Lower difficulty first, higher difficulty at the end. Some people like to do the fighting scientists first. Sometimes people like to do it last. Some people do the charts and graphs first. I just would go through the test normally. If you need to save time, skip the last question in each passage. That's the biggest chunk of time that most people spend. And understand when you're getting low on time, you feel like you've been working on a passage forever. It's time to get a couple guesses in and move on, because you're not really making the most of your time. Hopefully you've taken these subjects in high school: biology, chemistry, earth science, or geology, and physics. I find some of the hardest problems are physics. Some of the easiest are geology. Biology can be wildly confusing, but I can decode it fairly well. But a lot of people just don't really know physics, and it kind of gets them. So here's your 3 main types of questions. Look it up. That's really very typical. Why do you think this is happening? And you have to pay close attention to what's going on. And then well, what if? What's a reasonable conclusion? Why do you think they had that experiment set up like that? So final thoughts on the test. Save time. Don't read through the instructions. You should know them already by now. I have them on the next page if you want to see them. You've got about 5 to 6 minutes per passage. Use all your time. It's very tough. If you get to the end of the test, you have a few minutes left, go back and reread the toughest passage. Some people should not do that. They should just finish the test and move on. So know what type of test taker you are, but some people should really go through it. You really got to rest up for this. When old people take this test, and by old I mean over the age of 40, they all say the same thing: I am exhausted. That was a long, hard test. So you want to just keep things moving, have a good rest, eat well for breakfast, get there nice and early, hit the bathroom 20 minutes before the test starts, bring some water, bring some snacks, leave your cell phone far away, all that good stuff. So now I'm just going to give you a pass to the test. Now I got a problem. There's your instructions. Pause if you want to read them. I got a problem in that I can't fit everything on there. So I will leave that up for a second, and then I will scroll down. You might have to go back and forth on the video. Questions 1 and 2 are on the right. Then 3, 4, 5, and 6. 3, 4, and 5. So again, I'll scroll up. And actually I'm going to zoom out a little bit, make it a little easier to see, and then I'll come back and zoom in later. So hopefully you've had a second to look through this. This is about X-ray spectroscopy. I can't pronounce it. And it's mineral compositions. There's 2 different minerals. I don't know what's going on here. I don't know how spectroscopy works. Spectroscopy. I have no idea how to pronounce it, but I can answer the questions. Which of the following elements emitted X-rays the same maximum intensity in both? And intensity is on this axis. This is one of the skills I've learned, is to look at your axes. And your energy is down here. And you might think, well, isn't energy and intensity the same thing? Totally different. Be aware. So which one has the same? If you look carefully, you should see that it's B, chromium, here and here. According to figure 2, and this is one of the hardest parts of the test for people, is make sure they're looking at the right figure. What is the center of order of blah 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 lowest relative concentration? And that would be the intensity. It's going to tell you how much concentration you have. If you look carefully, you should see that it's G. The energy, and this is a classic, it's called interpolation. Atomic number 22 would be between Ca and Cr. Now we're on the x-axis. CaCr is between 3.8 and 5.2-ish. And so you're looking at B between 3.5 and 5.5. 4, according to the first figure, maximum intensity is less than half of which of the following in mineral 1. So we go up and we look for maximum intensity, and half, we look for that, and we have to actually use the question, what do we have to choose from, and then go forward from there. If you do that, I believe you're going to get J. And suppose another mineral, blah, blah, blah. You go up and you look for MnSiO2, and you should find that they have peaks. Not the y-axis, but the x-axis. Peaks on the x-axis at 0.5, 1.9, and 5.9. So there you go. Let's talk about charts and graphs. That was just practice. It was a chart and graph problem, but let's talk about charts and graphs. Here's some of the graphs you can see, and here's how they can be used. I am not going to go through them. You can pause and read them if you want. Scatter diagram is almost always going to tell you to, kind of figure out what's going on there. Pie chart, percentages to 100, degrees to 360. And then other types of graphs. This is my personal favorite, logistic growth, as it maxes out a population for, deer in the woods. They can only get so many deer because otherwise they eat too much and they all die off because there's no food to eat. And exponential growth and decay. So here's an example of what I would call a really interesting graph. And I will go through it, pause and read it. They basically go out in the woods and dig a hole, and then they say, well, when are things showing up, like pond scum or adult amphibians, which I always think is dad taking his kid to a ball game. I don't understand that. Long-toed salamander, which looks an awful lot like an ant. And the longer you go, the more these things show up. They must be attracted from other water bodies that are nearby. So they just have these weird graphs and things like that. And then they've got things like this. Hey, look at the number of tadpoles. It's going up. And I'm not getting ink all of a sudden. And look at the percent vegetative cover. It's going down. Lost my ink. Whatever. Why would that happen? Well, I would guess that the tadpoles are eating the vegetative cover, and that would be the answer to a question like that. Here is another chart tying in with this. Somebody went out and studied, what's going on where. And the fun part about this is that the key up here in the top right tells you that you've got 25 amphibians for every dot. Because people look and say, oh, there's 2 in the most up left here of the tree frog. That means there's 2 of them. Well, no, it means there's 50 of them. So you got to read. You can play with this if you want to. I'm going to scroll through it. This talks about sunburn, and when you get burned, how badly you got burned, and what happens in your melanin production. These are just typical types of charts and graphs you would see. This is, if you have serious sunburn, here's your chances of getting certain things. And then they put all this nonsense down here just to mess with you. And they talk about years and the number of cases per 100, all this sort of stuff. So here's common questions for charts and graphs that you'll see. Extrapolate, interpolate, what's the key, what's the units on the y-axis, what's the units on the x-axis, so on and so on and so on. So here's the drill. All right, read that, go through the chart, and start answering questions. I'll zoom out a little bit. Sorry for the constant back and forth. There's question 2. Should be pausing this and going back and forth and reading. Question 3. And question 4. And question 5. So if you went through this, which of the following statements best describes the changes at T2? Simple one is a lower kinetic energy. So you say, well, no, it's to the right more. Well, that's temperature, or it's activation energy, and then number of molecules in motion. It's confusing. I'll leave it at that. Number 2, assuming that water undergoes a phase change, which of the following statements would be true? F, and that goes back into the reading, which you'd have to find it in. The intermolecular forces of the escaping molecules are weak. 3, you're looking at B, same kind of answer to the question we just had. 4, looking at F, that is as close to prior knowledge as I've seen. I haven't talked about this. I should have. How well you want to read the passage is up to you. Everything you need to answer is almost always on the page. 38 to 39 of the questions can be answered without prior knowledge. But this is actually one where you need to know what the word evaporate means. It's always a little bit of vocabulary. And number 5 confuses people, but we're looking at C. Go back and check that out. Hopefully it makes sense. Here is another chart and graph. This one people like better because you can actually put your hands on it. I'm talking about tadpoles. They're dipping them in a solution and seeing how well they grow with this, what do they call it? There's concentrated thyroxine, which is a hormone. So there's 2, 3, 4, and 5. Pause, scroll back and forth, see how you do. All right, so 1 is B. 2 is G. 3 is C, and the key word here is least development, not most development. 4 is G. This bothers people. They say it says it starts with cell determination. Well, yeah, but you got to be a tadpole first. And 5 is C. And that you can look up here and see that the dots are together at 12 hours. After that, they start to break into different paths. Charts and graphs, drill 3. One of the things they teach you to do is to put arrows on your charts and graphs from lowest to highest. A lot of people like this. I just would say be very careful. Sometimes it's, whoops, no, now it's down. Oh, then it's up. So you don't want to have to do that. You just want to be able to draw one line. Otherwise, make a note in your head. There is only the one line. So there's questions 2 and 3. There's question 1, 4, and 5. So 1 gets a lot of people. It's A, not B, because if you look at the chart, it's going down more rapidly early on and then less rapidly later on. 2 is J. Nonmetals are down here at the high electronegativity. 3 is B, and that's what the arrows are for. 4 is G, and that you just have to look and compare. 5 is A. So they have this weird thing, ionization energy follows the same trend as does electronegativity. So you have to go and get them increasing. Always watch out when they put something in capital letters. And that's it. This is an actual ACT problem. So again, I am just going to scroll, and I'm just going to give answers. This is a biology question, which I couldn't tell you what a globin is. I would say watch out. This is the birth of a person. These are gestation, but it's 0 weeks from conception, so watch out. That always got me. Scroll back and forth, and it's the second passage, so it starts at 6, so don't be surprised or alarmed by that. And these are actually all the questions, so you can scroll back and forth as necessary. I'm not going to get into it. I'm just going to put the answers up now. F, D, F, B, G. Again, if I'm going way too fast, which I feel like I am, you just have to pause. Here's a charts and graphs. Almost looks like an experiment, but it's not. So you have to go through this one. A parallel plate capacitor, and it's got stuff inside it. And there's question 30 already. There's table 1. And then on the back side, we have questions 31 through 34. So again, just going to scroll through. 30, the answer is J. 31, the answer is A. 32, the answer is H. 33, the answer is D. And 34, the answer is F. So that's charts and graphs. A lot of material there. Hopefully you could decipher the real ACT questions, because I didn't go through why answers are what they are, but I just thought I'd give you the correct answers. So look carefully. Whenever you're looking at a question and you're like, I'm sure I got that right, I don't see how I got it wrong, go back and reread the question carefully and detailed. Look for every single word. Put your finger on the page and follow every word, and you will finally say, oh, I missed that word, or oh, I didn't read the right chart, or I didn't see the right figure, or I was looking at the wrong spot. That's it. We'll see you in a little bit for experiments.